Okay, we talk about the properties, the physical properties. Physical properties are the hardness. Okay, hardness means, I mean, the scratching. If I mean material, if you will scratch at the top, then you would not be able to scratch the material. That is known the hardness. Hardness is different from the strength. Strength means you cannot break them. Okay, hardness means you cannot scratch them. Okay, if you are trying to scratch and they are not being able to, having any kind of the line marks or whatever the things that you have tried to mark over there, that is known as your hardness. Okay, and brittleness, I have already told you, brittleness and the ductility, just opposite to each other. If you cannot stretch a material, that it means brittle. I mean, before the break, keep in mind, I mean, whenever we talk about the stretch, so it means you are stretching the material before the break. Okay, so in brittleness means that the material will break directly without stretching the material. Okay, but in a ductile, in a ductility, the material will first elongate themselves and then they will break. Okay, so they have a tendency. They will show you. I mean, when the material is going to fail. Okay, and in brittleness, they will break suddenly. Okay, how is a melting point? I already told you melting point means, I mean, if you supply the energy, it means supply the energy means that you're trying to give the heat to the material. They will, how when they will melt, start melting. I mean, at the beginning you have this solid material, okay, and at a particular, because why they are in the form of solid material, because the room temperature that we are live in, that is at the less temperature where it can stand in a solid form. Once it gets the high sufficient temperature, all materials will come down to the liquid form. Okay, so the liquid form of the material at what temperature? That temperature known as the melting point. And if the melting point is high, then it is known as the high melting point. Simply, okay. So melting point. Yeah. So if we talk about the ceramics, then it has the extreme temperature. I mean, extreme. I mean, a very high temperature is required to melt the ceramics. As compared to, suppose aluminium. Aluminium is a material, right? That's not ceramics. Okay. So aluminium can melt just at 800 and 900 degrees C, right? But if we talk about some kind of this, ceramics uh, zirconia, right? Zirconium oxide, aluminum oxide. Okay, so these are the ceramics. They cannot easily, melt at a 900. They need around 1400 or 1600 kind of material. Sometimes 7 degree, 2700 degrees C. Okay, so different kind of the ceramics are present. The very common ceramics are the sands that we see in our daily life. That is known also the ceramics. Okay, so we talk about the electrical properties. This was just a physical property. We talk about the physical properties. Okay, so electrical properties. It is an insulator. Insulator means which cannot pass the electricity. So the electrons cannot move through the material. Is known as the insulators. Okay, so most ceramics are excellent electrical insulator. Insulator means they cannot pass the charge electricity. Okay, so which is insulator. So as you can see, I mean, the sand that you have already known about that. That is the very common example of ceramics. So is the ceramics able to pass electricity? No, definitely not. Right. Okay. The next one is semiconductor. Semiconductor means the material which can conduct the electricity, but with the kind of modifications. Okay. That's another semiconductor. Very common semiconductor is silicon. Silicon is very abundant in this earth. Okay, and very common, very cheap material, and is very common example of the semiconductor as well. Semiconductor means which is not a semiconductor means conductor. Semi means half in between. So with the help of some external uh, modification, you can use that material as a conductors. That is known as a semiconductors. Okay, so thermal properties, thermal insulator, obviously low thermal conductivity, making them suitable for the heat shells. Okay, so all ceramics are uh, insulator of for the electricity and for the heat as well. Okay, as you have seen here, the insulator, they cannot pass the electricity, right? So it's a uh, bad conductor of electricity and also the bad conductor of heat as well. Okay. refractoriness can maintain the strength at the high temperature. Okay, so these are the chemical properties: corrosion resistance and inertness. Inertness means they cannot interact with the other element. Is known as the inertness. Okay, and we talk about the corrosion resistance. Corrosion means, I mean, the other foreign materials, for the foreign particles, which you know. Um, which basically collected at the surface of the material, like the rust at the iron, which is known as a corrosion. Okay, so it has a corrosion resistance, means they cannot have the corrosion at the surface. So it's a very good quality of the ceramics. Okay, because ceramics, we basically, I mean, the corrosion is a bad kind of the things which which is not desirable. Okay, in engineering applications. So we want the material that must not have the corrosion. Okay, so what we can do, we can apply the material which is corrosion resistance. So sometimes have you heard about the composite materials? The composite materials are the materials which in which two kind of the materials have been mixed together. Okay, in a different ratio, in which most of the times the ceramics are taken in a very less fraction of the volume, so that only to increase their corrosion resistance and their hardness. Suppose the materials which is, I mean, suppose aluminum. Aluminum is the very soft, I mean, is a very soft kind of materials. Okay, but you need to increase their strength. Okay, need to make increase your hardness. Okay, need to make that material as a corrosion resistance. Then what we do, we sometimes mix or the some other ceramics in a different ratio. Okay, so that to make a composite which have the different combination of the properties that both have. Okay, which is very common in these days in engineering application. The composite materials are widely used throughout the engineering across the world. Okay, so that the desirable desirable properties that we can basically collect from the different materials by combining them together as a uh, composite materials. Okay, so corrosion resistance, basically the material which basically resist the corrosion. Okay, which do not have tendency to corrode themselves. Corrode means, the foreign particles will come at the surface and they will erode them. Okay, that is the corrosion. Okay, so that will uh, directly or indirectly, less the, I mean, they will decrease the material strength, because I mean the material, if the surface area is going to be eroded frequently, what does it mean? It means you are having a less material and you are basically weaken the material. So strength will compromised. Okay, with the by due to the corrosion. Okay, so corrosion resistance is the most important properties. Okay.